As we study and work with functions, we always need to keep track, if nothing else, in the back of our mind, what is the domain and the range. So in this video, we're just going to do a quick little reminder of what domain and range are and look at examples of finding domain and range from different relations. Again, when we talk about the domain and the range, we're talking about a list of the possible values. So we're not really saying how does X relate to Y. We're not looking at the patterns. We're just saying what's possible. What can you input? What can you output? So with the domain, we're looking at the input. Generally, it's the X variable. Not always, but on the graph, it's always going to be on the X-axis, which is an independent variable in our relation. The range is still a list, but it's looking at the output. So we're putting that on the y-axis, so we generally think of y as the dependent variable. When we're listing the range, we're saying what are the possible outputs? What are the answers we get when we plug a number into this equation? Let's look at some example relations and find the domain and range. This first one is what we call a mapping. We're saying, how do we map these input values to the output? So for example, if x equals 5, we follow that along and we're saying my output's going to be 4. When we're talking about domain and range, again, remember, we're just talking about a list. So my input can be -2, can be 0, can be 3, or it can be 5. And I use these brackets, I believe they're called braces, to indicate that's just a group of numbers. We normally write them in order from smallest to biggest. We don't really care how they relate to the y values. In this case, they're already in order. That makes it easy. When we talk about the range are the output values. So again, we'll say we have a set, and here we have 2, 4, 6, or 8. And when we just have the numbers, it's pretty straightforward. That's all there is to it. When I look at this next relation, this relation is just 4 ordered pairs. Again, we're using those braces to say it's a collection of ordered pairs. But when we talk about the domain, again, we're just listing. So we'll say, what are my x values? Again, I like to make them from smallest to largest. So I got a -3. I have a 1. I have 4. And I have 7. And that's my domain. My range is the output, which are my y values. So I have a -2. I have a 2. I have another 2. I don't care. I already have listed a 2. I'm listing what's possible. And I have a -4. I should have written that first, so I'll put it over there. So I don't necessarily have to have 4 numbers in my range, even though there are 4 values, because I got 2 2s. I don't repeat. I'm just listing what's possible. So I'm not going to repeat values. If it shows up more than once, I got it listed. It's taken care of. This last one's on an XY table. Again, as I'm looking at the input, I'm just looking at the x values. So x can be -2, x can be 0, x can be 2, x can be 3, and x can be 5. When I look at the range, I'm looking at the y value. So y can be 3, or y can be 5. I don't have to have the same number of numbers in the range as I had in the domain. I'm just listing what's possible. So, again, domain, I look at my inputs. Unless we say otherwise, we're going to assume x is the input. So I just list what I have, 0, 2, 3, 4, 8. And please, I don't just circle this whole column and say that's the domain. I list them out. I say separately, this is what my domain is. My range is the output, so I look at my output values. I have a -9, a -2, a 3, and a 5. Domain and range is really easy if I just have a list of values, whether I have a table or when I have coordinate pairs or like that mapping where it just says, here's the input numbers, here's the output numbers. It gets more tricky when we start looking at equations. So when we look at this one, this relation is showing x in relationship with y. That's one of the reasons when we're looking at these, we're going to learn some ideas with these different types of functions. What is the domain and range for these different types of functions? What are the things you watch out for? Normally, or often, what's more important is instead of what can x be or what can it not be, we look for problems. What can it not be? And if I look at this equation, y equals 3x minus 20, I try to think, are there any values of x that I cannot plug into that equation and make it work? And for a nice linear equation, there are no problems. So my domain is going to be all real numbers. And our abbreviation for all real numbers is going to be a capital R. It's supposed to be a boldface R. This is how we write it when we're just using a pen or something. We put the double stroke on the R to say that's a boldface R. But x can be any number we can deal with. And again, if I think about what a line looks like, a line is going to look something like this. It's going to go on forever. X will go on forever. Y goes on forever. So y, again, the output, can be any real number. When we look at this last one, a graph, actually a lot of times it's easier to look at an equation if I can see a graph, because with a graph I can see exactly what's going on. When I look at this one, it's going to the right forever. It's going to the left forever. So it can have any value of x would work in here. So I'm going to say my domain is all real numbers. When I look at my y, my output, it's going up here at the end, so it'll go up forever. It's going down at the end, it'll go down forever. There's no gaps in between, so this is going to, again, be all real numbers. So what does a graph look like that does not have a domain of all real numbers or a range of all real numbers? When we look at this first graph, you notice it has an arrow on this end, meaning it's going forever in this direction. But on that end, we have a dot. This is a ray, if you remember from geometry. So my x values start at -3, and we go on forever in the positive direction. So on my domain, I'm just going to say x has to be greater than or equal to -3. My range, the y starts at 2, and then it goes down from there, and it's going to go down forever. So my range, I'm going to say, is y is less than or equal to 2. When I look at this next one, we're starting, or with blah, blah, blah. Okay, let's try this again. We look at this next one. When we're looking at our domain, it's going to the left forever. It's going to the right forever. I can still have any real number for an input value on this graph. But when I look at the range, it gets down to -2, and it goes up from there, but it never goes below negative 2. So again, my range, I'm going to say my y has to be greater than or equal to negative 2. Finally, in this last one, my x values are here between negative 4 and 5. So my x values have to be less than 5, but bigger than negative 4. So I'm going to write my domain as a compound inequality. X is between negative 4 and 5. My range, I'm between 4 and negative 5. So negative 5 is going to be my smallest value. 4 is going to be my biggest value. So I would write my domain and range this way.